Welcome. This session will discuss how big the energy demand is and how much bioenergy can be provided. We will do this by the example of the European Union. The principal considerations behind are valid for any global region. Just to remind you, non-renewable energies are provided by fossil oil, gas, coal, and nuclear energies, and renewable energy sources include wind, solar, hydro, and tidal power, geothermal energy, biofuels, and the renewable part of waste. All data I will present are available online from different sources, such as Eurostat and the European Biomass Association. The difficulty in analyzing and evaluating these data lies in the fact that organizations use different energy units. Common units are shown on this table: joule, calories, watt-hour, thermal unit, and more. Converting these units by recalculating is possible, as shown on the right, but nevertheless it is hard to compare different energy units. I prefer, therefore, to show the very same unit for all energies, and as mineral oil still is one of the most important energy sources, I will use in this session the unit of oil equivalent. The ton of oil equivalent, its abbreviation is TOE, is a unit of energy defined as the amount of energy released by burning 1 ton of crude oil. The other difficulty is that the term energies is used in different ways. Used in a correct way, this term includes all energies. But sometimes only electrical energy is meant, which obviously is only a share of total energies. When calculating the share of renewables, this different use of the term energy results in a different data set and confusing results. In this session, energies always means all energies in the unit of oil equivalents. In 2016, the European Union consumed more than 1 million kilotons oil equivalent. This is heating and cooling, fuel, and electricity in industries, services, and transport. Please have a look on the yellow field. With a share of 42%, the most relevant consumers are commercial and public services, residential use, for example heating, agriculture, and fishing. Industries, the blue piece of cake, require 25%. These are energy-intensive sectors like iron and steel, but also the food sector. Transport on rail, on road, aviation and navigation consume another 33%. Obviously, all of us consume energy in some way or the other. Now let's have a look on the share of renewable energies in the total energy portfolio and on bioenergies with the renewables. The share of all European renewable energies has been 17% in 2016. Ranking number 1 in renewables is electrical power. 30% of electrical power are generated from biomass, water, wind, solar, and more renewable energies. With a share of 18%, renewables also contribute significantly to heating and cooling. The share in the transport sector is 7%. The part of renewable energies we are interested in this session are the bio-based energies. As is shown here in green, in fact, bioenergy contributes to all sectors of renewable energies. It is 6% of electrical power, 16% of heating and cooling, and 6% of bio-based fuel. Please note that renewable heating and cooling and transport fuel are almost completely bio-based. Heating is dominated by food chips and pellets, and transport fuel is almost completely biodiesel and bioethanol. Altogether, bio-based energies provide about 115,000 kilotons oil equivalents, which amounts to a share of 10% of energy supply. Now let's have a look on the feedstock portfolio providing these energies. In fact, it is highly diverse. The graph on the left shows the situation with biofuel. Vegetable oil and some animal fat dominate, with rapeseed oil leading. The share of all oils and fats amounts to 80%. This fact demonstrates, on the one hand, the importance of biodiesel in Europe, and the other, the load of biofuel on agriculture, as currently, for example, 49% of rapeseed oil is used for energy purposes. Sugar-based fuel, which is mostly bioethanol, originates from wheat and corn and amounts to 20%. 75% of biogas is produced from crop, bio-waste and manure, but also landfill gas as well as fermenting sludge are relevant. The feedstock portfolio of biogas depends very much on the specific regional supply. In Germany, for instance, not only bio-waste is fermented, but also energy corn, specifically cultivated for biogas fermentation. When it comes to heat and power, lignocellulose, or in other words, wood and woody biomass, take the lion's share with 75%. This is why bioenergy is leading in renewable heat and power. Now, in spite the share of bioenergies is only 10%, it consumes already today a significant share of biomass. As you can see on the left of this slide, Europe produces annually about 800 million tons dry matter biomass, 600 million by agriculture, 200 million by forestry, and a little marine biomass. In addition, 200 million tons are imported. The graph on the right explains that 60% of that biomass is used for nutrition in the food and feed sector, 19% in biomaterials, such as timber and hemp fibers, 2% in other applications like biopharmaceuticals, tobacco and flowers. The sector of bioenergy asks for another 19%. Now, the fact that 19% of total biomass supply deliver only 10% of energy should raise a question. How much further growth in bioenergy is possible? Several studies analyzed the sustainable potential for bioenergy feedstock. They considered the food versus fuel conflict, the impact on land use, on greenhouse gas, biodiversity, societal implications, and more sustainability criteria. The biggest growth potential in bioenergy feedstock is seen in bioresiduals, as it is shown on the graph of this slide. Agricultural and woody residuals and manure amount to 75% of the future potential. Also, in the remaining share of small volume materials, many deliver energy in the form of lignocellulose. All materials are classified as a residual or waste. Primary biomass from agriculture, forestry or marine sources is not considered a sustainable source for bioenergy. Consequently, all studies shown on the right come to the conclusion that there is a limit in bioenergy capacity. It is estimated in the range of 150 to 190 million tons of oil equivalent. Compared to 115,000 million tons of oil equivalent generated already today from biogenic feedstock, the future sustainable growth potential is estimated at about 30 to 65%. There is no doubt that in order to put future bioenergies on a sustainable basis, we need to accept these limits, and it is therefore recommended to adopt a European-wide limit on the amount of bioenergy, exclude high-risk biomass sources such as biomass from protected areas, limit the extraction of agricultural and forest residues to safe levels, ensure that biomass for energy doesn't displace other existing uses, ensure affected communities free, prior and informed consent, introduce a minimum efficiency threshold, increase investments of renewable energies other than bioenergy. On the one hand, we need bioenergy in the renewable portfolio, but on the other, it needs careful and cautious planning when growing bioenergy within the broad portfolio of renewable energies. Energy markets are big, important and demanding. However, restricting bioenergies to sustainable capacities is the only way to ensure bioenergy on the long range.